Hello everyone, I am Vijayvarthini, Department of Physics. Our topic is elasticity. Stress. Stress is defined as the restoring force per unit area. If a force F is applied normally to the area of cross section A of a wire, stress equal to force by area. Its dimensions are m l minus 1 t power minus 2. Strain. When a deforming force is applied, there is a change in length, space, shape or volume of the body. The ratio of the change in any dimension to its original value is called strain. Strain is divided into three types. They are longitudinal strain, shearing strain and volume strain. Hooke's law. Within elastic limits, the stress is directly proportional to strain. E equal to stress by strain. E is a constant called modulus of elasticity. The dimensional formula of modulus of elasticity is m l minus 1 t minus 2. Its unit area are n m minus 2. Young's modulus. It is defined as the ratio of longitudinal stress to longitudinal strain within elastic limits. Longitudinal stress equal to force by area. Longitudinal strain equal to change in length by original length. E equal to FL by AL. Rigidity modulus. It is defined as the ratio of tangential stress to shearing strain. Now, rigidity modulus equal to tangential stress by shearing strain. G equal to F by area or angle of shear. Bulk modulus. It is defined as the ratio of volume stress to volume strain. When three equal stresses F by A act on a body in mutually perpendicular direction such that there is a change in volume V, its original volume V. Stress equal to pressure P equal to F by A. Volume strain equal to minus V by V. The negative sign indicates that if pressure increases, volume decreases. Poisson's ratio. The ratio of lateral contraction to the longitudinal elongation is called Poisson's ratio. It is denoted by the letter nu. Nu equal to mu by lambda. Work done in stretching a wire. Let a force F act on a wire of length L and the area of cross section A. The increase in length is L. Young's modulus Y equal to FL by AL. F equal to YAL by L. Work done in producing a stretching DL equal to F into DL. YAL by L into DL. Total work done to produce a stretching of the wire. W equal to integral F into DL. F equal to YAL by L. W equal to 1 by 2 YAL square divided by L. W equal to 1 by 2 YAL by L into L. W equal to 1 by 2 into stretching force into elongation produced. Work done in twisting a wire. Consider a cylindrical wire of length L and a radius A fixed at its upper end and twisted through an angle theta by applying a torque at the lower end. If C is a torque per unit angular twist of the wire, then the torque required to produce a twist theta in the wire is C equal to C theta. The total work done in twisting the wire through an angle theta equal to W equal to integral C into d theta d theta. W equal to 1 by 2 C theta square. The work done in twisting the wire is stored up in the wire's potential energy. Thank you.
Hello everyone, I am Nikita Sri from Department of Physics. Our topic is bending of beams. A beam is defined as a rod or bar of uniform cross section whose length is very much greater than its thickness. Cantilever. A cantilever is a beam fixed horizontally at one end of the loader at other end. This is constructions of cantilever. Let OA be a cantilever of length L fixed at O and loaded with a weight W at the other end. OA is the unstrained position of the beam. Let the depression A dash of the free be Y. Let us consider an element PQ of the beam of length dx at a distance from the loaded end. C is the center of curvature of the element PQ and R its radius of the curvature. The load W at A and the force of reaction W at Q constitute the external couple. So that the external bending moment which is equal to Wx. The internal bending moment equals to Ea square by R. Wx is equal to Ea k square by R. R is equal to Ea k square by Wx. Draw tangent at P and Q meeting the vertical line at T and S respectively. Let Ts is equal to dy and d theta equal to angle between the tangent. Then angle PCQ also equal to d theta. Now PQ equal to dx which is equal to ed into theta. D theta which is equal to dx into Wx by Ea k square. We have dy equal to xd theta. which is equal to x wx dx divided by EAK square. The total depression of the end of cantilever y is equal to WL by 3 EAK square. Next topic is oscillation of cantilever. The construction of oscillation of cantilever is given below.
Let OA be the cantilever of length L of negligible mass fixed at O. Let mass M be attached at the other end of the A. If the mass is slightly depressed and then released, the cantilever will execute simple harmonic motion about its original depressed position. The depression of the loaded end of the cantilever is Y is equal to W L cube divided by 3EAK square. W is equal to 3EAK square by L cube into Y. This must be equal to the elastic reaction of the cantilever balancing it and hence directed opposite to it. If m is the mass of the weight w and d square y divided by dt square, the acceleration we have elastic reaction m is equal to d square is equal to d square y divided by dt square. D square y divided by dt square is equal to 3 minus 3 EAK square divided by m L cube into y. But 3 ak square divided by m L cube is equal to a constant. The acceleration of the mass m, the free end of the cantilever is thus proportional to its displacement and is directed opposite to it. Therefore, it executes simple harmonic motion of time period t given by t is equal to 2 pi root of displacement divided by acceleration. 2 pi is equal to y divided by 3 k square divided by m L cube. 2 pi is equal to root of m L cube divided by 3 E A K square. If the mass of the cantilever is not negligible, it can be shown as T is equal to 2 pi root of m plus 1 3m L cube divided by 3 3 square, where m is the mass of the cantilever. If the mass of the cantilever can be eliminated by finding the periods T1 and T2 for two different masses m1 and m2 attached to the cantilever at the same length, then E is equal to 4 pi square m2 minus m1 L cube divided by 3ak square into T2 square minus T1 square. Thank you. Hello everyone, I am Rubini from Department of Physics. Our topic is ultrasonic waves. The definition of ultrasonic wave is our human ear is sensitive to the sound waves in the frequency range from 20 to 20,000 Hz. This range is called audible range. Sound waves of frequency more than 20,000 Hz are called ultrasonic waves. These waves travel with the speed 330 meter per second. Let's see about the production of ultrasonic waves. The production of ultrasonic wave is based on two methods, piezoelectric crystal method and magnetostriction method. Piezoelectric crystal method. This method is based on the principle on the inverse piezoelectric effect. The construction of piezoelectric effect consists of a quartz crystal slice and a transformer and a transistor and a capacitor. When a battery is switched on, the oscillator produces high frequency oscillation. An oscillatory EMF is induced in the coil L3 due to the transformer's action. The crystal is now under high frequency and alternating voltage. Now the crystal vibrates with a large amplitude due to resonance. Thus, high power ultrasonic waves are produced. Advantages and disadvantages of piezoelectric crystal method. Advantages: ultrasonic frequencies as high as 500 MHz can be generated. The output power is very high, so it does not affect the temperature and humidity. It is more efficient than magnetostriction oscillator. Disadvantages: the cost of quartz crystal is very high and cutting and shaping of the crystal is also very complex. Magnetostriction method. Principle: when a rod of ferromagnetic material like nickel is magnetized longitudinally, it undergoes a very small change in length. This is called magnetostriction effect. Due to resonance, vibration of large amplitude are produced in the rod. Ultrasonic waves are produced from the ends of the rod. Frequency F is equal to 1 by 2L into root of L E into rho. where L is the length of the rod and E is the young smallness of the rod and rho is the density of the rod. Construction. The construction consists of an transistor, battery and a variable capacitor working. When a battery is switched on, the resonant circuit L2C sets up an alternating current of frequency. F is equal to 1 by 2 pi root of L2C. This current flowing around the coil L2 produces an alternating magnetic field of frequency F along the length of the nickel rod. The rod starts vibrating due to the magnetostatic effect. The vibration of the rod creates ultrasonic waves. Thus, ultrasonic waves are produced. Advantages and disadvantages of magnetostriction method. Magnetostriction oscillator or mechanically record. The construction cost is very low. They are capable of producing large acoustical power with very good efficiency. Limitations: it can produce frequency up to 3 MHz only. The frequency of oscillation depends greatly on the temperature. Thank you all.
Hello everyone, I am Vinodini in Department of Physics. Now we are going to talk about surface tension. First of all, define surface tension. It is defined as the force per unit length of the line drawn in the liquid surface, acting perpendicular to it at every point and tending in pull the surface upward the line. This is called surface tension. Next, excess pressure over curved surface. See in this diagram. When the pressure on both sides is a liquid surface is same, then the surface is flat without any curvature. To find the excess pressure, consider a small curvature rectangular element A1, B1, C1, D1 of a liquid surface. Let P be the excess of pressure inside the surface over the outside. Then the outward on the surface A1, B1, C1, D1 equal to P into area of the element. A1, B1, C1, D1 equal to P into A1, B1 into B1, C1. Now let the surface be moved outward though a very small distance del x. Let the new position of the surface be A2, B2, C2, D2. Work done in the displacement equal to P into A1, B1 into B1, C1 into del x. Equation number 1. So A1, B1 divided by A2, B2 equal to A1, O1 divided by A2, O2. Next, A1, B1 divided by A2, B2 equal to R1 divided by R1 plus del x. So, A2, B2 equal to A1, B1 into R1 plus del x divided by R1 equal to A1, B1 into 1 plus del x divided by R1. Similarly, B2, C2 equal to B1, C1 into 1 plus del x divided by R2. Hence, A2, B2 into B2, C2 minus A1, B1 into 1 plus del x divided by R1 into B1, C1 into 1 plus del x divided by R2, increasing the surface area A1, B1 into B1, C1 into 1 plus del x divided by R1 plus del x divided by R2 minus A1, B1 into B1, C1. Work done in the increasing the area of force equal to surface tension into increasing a surface area. Sigma into A1, B1 into B1, C1 into del x into 1 divided by R2 minus 1 divided by R1. Equation number 2. Equation 1 and 2 we have P A1, B1 into B1, C1 into del x equal to sigma into A1, B1 into B1, C1 into del x into 1 divided by R1 plus 1 divided by R2. P equal to sigma into 1 divided by R1 plus 1 divided by R2. Next topic, surface tension by Jaggers method. Principle. The pressure inside an air bubble liquid in greater than the pressure outside by 2 sigma divided by r. Here sigma is the surface tension of a liquid and or the radius of the air bubble. Construction. Now see this diagram. This method is based on the principle that the excess pressure inside an air bubble is equal to the width of the surface tension by a liquid in which the bubble forms over the radius of the air bubble. Next apparatus, a large funnel, a short glass tube, a rubber tube, screw clip, beaker, traveling microscope, weighting balance, water, etc. Experimental details. If the stop clock B is opened, water flows the aspirant and the air in the aspirant is displayed. The displaced air force its way through the tube DE and forms air bubble at E. The size of each air bubbles gradually grows. When its radius becomes equal to the radius of the tube at E, it becomes unstable and breaks always. During the growth of the tube in air bubble, the pressure inside increasing and reaches a maximum value at the instant of detachment. The difference in manometer level H1 is noted just when the bubble detaches itself. The pressure inside the bubble equal to P into P1 equal to H plus H1 rho, where H is the atmosphere pressure, H1 is the difference in manometer level. Rho is the density of the manometer liquid. The pressure outside the bubble at the same time equal to P2 equal to H plus H2 into rho 2 into G. H2 is the length of the tube dipping in the experiment liquid. Rho 2 is the density of the experiment liquid. Excess pressure inside the bubble H plus H1 into rho 1 into G minus H plus H2 into rho 2 into G. G is a common, so H1 into rho 1 minus H2 into rho 2 into G. But the excess pressure inside the bubble equal to 2 sigma divided by R. Hence 2 sigma divided by R equal to H1 rho 1 minus H2 rho 2. Sigma equal to 1 divided by 2 Rg into H1 rho 1 minus H2 R rho 2. Thank you.
Good morning everyone. Today I am going to teach a topic on simple harmonic motion. In simple words, simple harmonic motion is nothing but is a oscillatory motion which experiences a restoring force or a opposing force, where the displacement of the particle is proportional to the acceleration of the particle. Let's go to the topic in deeper. If the particle P travels along the circle with the radius A and of a center O, then if the particle P travels along the circle at a uniform angular velocity, then the foot of the perpendicular M vibrates along the diameter y and y dash. If a P completes its one revolution, then the M completes its one vertical oscillation. The distance OM is known as the displacement of the vibrating particle, which is nothing but particle P. Then theta equal to omega into T. By the triangle MOP, sin omega T equal to OM by A. Sin omega into T into A equal to OM. OM is nothing but a Y, which means displacement of the vibrating particle. Then the velocity of the vibrating particle dy by dt equal to A into omega into cos omega t. Then the acceleration of the vibrating particle d square y by dt square equal to minus A omega sin omega t. Then the time period for this oscillation t equal to 2 by y omega equal to 2 pi into root of displacement by acceleration. Now we are going to learn free vibration or undamped vibration. What is meant by free vibration or undamped vibration? When a body oscillates in a vacuum, which means there is no external force or external force acts there, then the body continues to oscillate
at infinite times with a constant amplitude as there is no external force or external force acts on it. Acts on it. For example, we can say a simple pendulum. When a bob of a simple pendulum gets disturbed once, then the bob continues to oscillate at infinite times as there is no as there is no external force or external force acts as the simple pendulum is kept at the vacuum. Then the time period taken for this oscillation, we can say t equal to 2 pi into root of L by g. The time period depends upon the length of the pendulum and the acceleration of the particle, which is due to gravity. Now, differential equation of undamped vibration. Let m be the mass of the particle. Then kinetic energy of the particle. Kinetic energy equal to half into m into dy by dt whole square. Potential energy equal to half into k into y square. By adding these two equations, m into d square y by dt square plus k into y equal to 0, which means constant. By dividing this equation by m, we get d square y by dt square plus k by m into y equal to 0. It is a differential equation of undamped vibration where omega equal to k by m. Then the time period for this oscillation t equal to 2 by omega, which is equal to 2 by root of k by m. Y equal to a into e power pt. Substitute y value in the equation. Then we get the equation a into p square into e power pt plus 2b into a power a into p into e power pt plus k square a into e power pt equal to 0. By cancel out in the common terms, we get p square plus 2bb plus k square equal to 0. By finding the real roots formula, we get b equal to minus b plus or minus root of b square minus k square, where k square is greater than b square, then it is an imaginary equation. And then we get the equation y equal to e power minus bt into a power e into e power I beta into t plus b into e power minus I into beta t, y equal to e power minus b into t into a into cos beta plus I beta t plus b into cos beta t plus I sin beta t equal to e power minus bt into a plus b cos beta t plus I a minus b sin beta t. Here we a plus b here we are taking a plus b equal to c cos gamma, then a minus b as c sin gamma, then we get equation y equal to c into e power minus bt into sin into beta t plus gamma. The time period for damped vibration t equal to 2 pi by beta equal to 2 pi by root of k by m minus mu square by 4 m square. The time period of damped vibration is greater than the undamped vibration, then the oscillation of a damped vibration particle comes at rest. The time period for which damped vibration is greater than the undamped vibration.